Hello and welcome to this tutorial about scripting SteamVR Basics. What I'm going to do here is modify a scene that we previously created in another tutorial about SteamVR Publishing, which did not involve any scripting. But if you need a refresher on how I got here using the camera rig and SteamVR here with my HTC Vive or any other SteamVR compliant headset, just check out that tutorial. The description should be in the link. And next, I'd like to show you actually how to do some teleporting, and then we'll actually get into scripting or configuring and scripting the handset input. So I'm going to go ahead and disable the camera rig from the SteamVR camera rig. So now we have no cameras really in the scene, but down in your project, if you have SteamVR imported properly from the asset store, which is covered in a previous tutorial, I'm going to go into the SteamVR folder, and inside of Interaction System there's a folder called Core, and then there's a prefabs folder in there for prefabricated objects. So what I need here is the player, and that's going to be basically like your VR user, and I'm just going to place it in the scene, and then I guess I'll copy the camera rig's location and orientation by selecting it and then right clicking on transform and saying copy component, and then for player I'll just paste component values. Now it's basically in the same spot that we've been working with this project, and all this is like a collider that will be your head, and then your hands will be generated next to it. So I'm going to raise this up above the terrain, the green here, this collider. I'm going to make that a little smaller. So to make icons smaller or glyphs smaller, they call it gizmos in Unity. You can hit this here and it will actually shrink it, make it smaller or bigger. That's a collider, so I just wanted that to be above the terrain here. For teleportation, all I'm going to do here is go back into the SteamVR folder under Interaction System, and there's a folder called Teleport, and they've already kind of created this for us. So we're going to go into prefabs, and there's a prefab here called teleporting. You just drag that into your scene anywhere. It's just sort of like the way that's configuring the teleportation systems, like all the characteristics of it, even the sounds that go along with it. Alright, now with teleporting the scene, that just configures all the characteristics of teleporting. The next thing we need to do is actually create a surface that we would want to teleport on. So there's two ways we could do this. We can just turn regular geometry. Unfortunately, we can't use the terrain itself unless you have a mesh that is your terrain. But you're kind of defining where a person in VR can teleport. So I'm actually going to create a new 3D object, like a plane, real quick. So right-clicking in the hierarchy, or you can go to Game Object, 3D Object, Plane, and then there we have that. And I'm going to move this so that it's somewhat nearby, but sort of above the ground. And this will be like an area that we can teleport around on. You can of course scale it and change it however you'd like. But this limits kind of where your VR user can actually go to, and if you need to rotate it, you can do that too. So it's unfortunately not going to be mapped exactly to the terrain unless you have a mesh object that is the terrain. So this plane kind of looks ugly, so we need to actually make it a terrain or a teleporting object. So with it selected, you want to add component and search for teleport area. Okay, so then it basically changes the way it looks into this sort of the shader that comes with SteamVR. To disable that coloration or change it, you can modify the teleport visible area material here. I'm going to leave it alone so that you can see kind of what we get. So with one of my handsets on, I'm going to put my VR headset on, and by default they already have these gloves rendered to your handsets. But if you press your thumb on the touchpad and hold it down, you'll see that there's this nice interface all configured, and we can teleport around. There's sound that goes with it. These are all parameters that can be changed, and now we're teleporting around our virtual world sort of as a pretty quick setup to do that. Alright, so let me show you this other type. It's called teleport points. So real quickly before I move on, I want to clear up some confusion that a user brought up to me. So I am using player here, and I have camera rig turned completely off, but it's still in the hierarchy, so it's grayed out and we're not using it. And the reason we're using player is because it's configured to use this teleport area or teleport points, which I'm going to show you here shortly. And camera rig is not set up to do that. And I've tried to modify camera rig to do it, and it just doesn't work. There's probably more I could do to get it to work, but at this moment in time, I've never really gotten Camera Rig to work with the Valve teleporting configuration here. I've got it working with my own custom written things, but not with this. So anyway, using player, the confusion comes in if you watch here. If you watch it in the hierarchy and I hit play mode, it disappears, or it seems to disappear. Right, so users were watching my tutorial and they zoomed in and they saw that Camera Rig was here and they didn't see player, and they were thinking, well, what the heck, are you using Camera Rig? No, player actually ended up down here in this object called Don't Destroy on Load. So if I twirl that open, there it is right there. And the reason it does that is Valve changed their software a little bit, and it's kind of smart. So they put the player object in that Don't Destroy kind of grouping. And what that grouping is for, it's a Unity convention or technique, and anything that's put in here will not be destroyed when you load other scenes. So if you imagine you've got a VR headset that is hooked up with drivers and the graphics card, and all this software has to daisy chain together and then feed into our player instance that's configured here in our application. And you wouldn't want to decouple that whole chain of software and recouple it every time you load a new scene, because it might cause issues down in the chain. So what they've done is they persist the user object between scenes here, and then that way you don't have to worry about the VR headset causing errors if you load your scenes and it takes too long to load your scenes, or something in another scene causes an issue. So it's just a clever thing that Valve did, and you can also set your Camera Rig up to be do not destroy on load. There actually is some documentation on the Unity website called Object Don't Destroy on Load. Any object that you want to not destroy on load, you can just reference the object and say don't destroy on load, just like they're doing right here. We're just saying, actually it's don't destroy on load, and then you can use a parenthesis, and then you could put your object in there, and then at the moment of execution for this line, it will get added to this category here, and then you can continue to use it scene by scene by scene. So sort of a clever feature. I wanted to resolve a little confusion there, and let's move on to working with teleport points now. You can just leave any teleport areas there and mix and match teleport points with teleport areas. So I'm gonna go back into SteamVR. I've got it up here, but if you're in SteamVR in the same teleport folder in prefabs, there's a teleport points object, and you can just drag this out, and so you basically place them out kind of like stepping stones. They have to be near each other, because when you teleport, your curve, the Bezier curve that comes off of your controller, it's only so long. Let's try this. Alright, so if I hold down the touchpad, you see I can see the teleport area we created, then here's these points. And I have to basically put the cursor, or my Bezier curve here, right on one of the points, and that takes me there. But I can't teleport anywhere else around that area, but I can just hit those specific points. And then if I hold the button down, they show up, and then if I release, they go away. Okay, that's teleport points and teleport area. You can expand off of that pretty extensively, and it becomes quite useful to just explore a virtual world you created, like using Unity Terrain like I showed you here. Unity Terrain was covered in a previous tutorial as well, so just be aware of that. If you want to learn how to make terrain like you're seeing here, or even put in objects from Google Poly, that's also created in a previous tutorial. So to detect the button presses, that's already taken care of. We saw that already in action during teleport, so I want to show you where that's at. Go to Window, SteamVR Input, and here we have this SteamVR Input menu with all these actions built in. Now I mentioned teleport. That's an action they built by default, and if you look here when I click on it on the right, it's of type Boolean, so that makes sense. It's a button. You're just kind of pressing on and off to use the teleport function. And in their scripts, they're making use of that specifically. And that is already bound to the button that is our thumb pad, and we can see that by pressing Open Binding UI. And that brings open this website that's served off your hard drive where you have SteamVR installed. And if you have your handsets turned on and SteamVR is turned on, it will automatically display this Vive _ controller or whatever type of controller you're using, and you can hit edit. and it will show you what it understands about your controller. So we're looking at default right now. So if I kind of go down here on the left, we can find trackpad, use as button, click teleport. And actually for you probably won't see this one. Let me get rid of that. I was testing things earlier. So this is actually by default what you're going to see here. If I hover over this one, you see there's this line annotating the touchpad itself, and it's using the teleport action. That's how to understand that. Okay, so we don't have a way on this trackpad to actually determine the axes, like where your thumb is on the surface, and we need the button press and that to detect like where you're pressing on the trackpad. So let's go back into Unity here, and if you go through the list, let's see if there is something for axis. So this is a Boolean, interact UI, grab pinch. Nope, doesn't look like it. So all of these are values that are used by default in their action set. We need to make a new one. And again, I was testing here, so I'm going to remove that. So we're going to press this plus sign here, and you'll see new action, and type in touchpad touch. It doesn't have to be that specific keyword, but that makes sense to me, touchpad touch. And the type of value we need here is actually a vector 2. So you hit this drop down, go to vector 2. We need to know the X and Y axis of where your thumb is on the touchpad. And you can leave the rest of the items alone here, hit save and generate. And that just makes the action item itself. It doesn't link it at all to the handset. So we have to do that next using that binding UI. So once your background flashes and it comes back and it's saved, open the binding UI once again and go into your local controller changes. And then looking down through the list here, we want to modify the trackpad so that we also detect the 2D axes. You want to hit this plus sign here, and we're looking for the trackpad itself. Okay, there were other options in that list. Of course, you can expand upon this tutorial in the same way I'm doing this and look at other ways to detect actions with the other buttons on the controllers or the tracking data itself. And on the trackpad, there is the click, the touch, the position. We only have one value that we need to associate because teleport's already taken care of for the button press. So position is just what we need to detect. So we'll say none, or click the none button, and then it's showing us anything that's available that is a variable that can take the position data. So touchpad touch is what we need. Actually, it's an action, sorry, not a variable, but it's going to look like a variable. It's a reference, really. So we're associating that, and then you can hit this checkbox here. Now that's there and linked. So now the handset's linked to our action that was in the action set. We have to replace the default binding, so click that, and then hit save. And then if you wanted to see the output that's coming from this fancy website configuration tool, you can hit show developer output, and this is actually what you're modifying. It's just this JSON file that's right here, which is not, it's human readable, but it's not easy to work with, so that's why they have this nice website. All right, you can close this. So that's all stuff that happened kind of in the background to link up that value. Now I'm going to show you actually how to script with that. So go ahead and make a scripts folder if you don't already have one down in your project, and right click and create a new C# script. And I'm going to name this VR input. Okay, go ahead and open that up if you have that created. Okay, so right away we need a link in our script to the Valve libraries, so let's make that. So at the top here, just put in using valve.vr, semicolon. So this is different from the Unity engine.xr if you're familiar with that. We don't need the start function in this, so I'm just going to delete that. Just make it look simpler here and get rid of the comment. There we go. So we're going to do basically everything in the update function here so we can detect these inputs. All right, so the first thing we need to do is link this script to the actual handset kind of API library that comes from Valve. So we need to actually reference what we're looking at. So the first thing we need to do is make a public variable, which is kind of cool because the data type we're using is a Steam data type that allows a drop-down menu in the inspector. So it's SteamVR action vector 2. with underscores in it. So SteamVR action, I'm going to just enter that, underscore vector 2. Okay, so that's a data type that comes from their library. And I'm just going to name it touchpad action, just because this is what's going to link up to the device and what's already set up by Valve. So going back into Unity, I'm going to place this script on our camera rig. You can put it anywhere in your project, but the reason I wanted to do that is so I can show you what happens in the inspector. So camera rig itself, I was testing earlier, so let me remove that. I'm just going to drag this up onto camera rig. There we go. And there it shows up. And that public value now for the SteamVR action vector 2 input is now a drop down, and it shows us everything here that is a vector 2 that we can associate with. And in some of the other actions, like platformer and buggy, they have other vector 2s, but we're not paying attention to those. We're using the default actions, and those specifically the vector 2 we made, touchpad touch. So I'll associate that, save, and then I'm going to head back into scripting here. And we need to actually store the values that come off of this. So we need to know when the touchpad is pressed, which would be a Boolean, kind of an on-off, which is actually from teleport, not the touchpad touch value. But we also need the touchpad touch value because that's a vector 2. We need to store that somewhere, like an axis. So I'm just going to make two variables here that we're going to use in this script. So the first one will be to detect the button. So we'll just call it pressed. And I'll initialize it as false. And then for the vector 2, I'm going to name it axis, and it will initialize by default to all zeros, and that's what we want, so I'll just leave that uninitialized in the code. And then down in update, let's first start by detecting if pressed has happened or not. So we need to do an if statement, and we're going to look into the SteamVR actions with an S, and within that we're going to look for our default actions. So you'll see a whole bunch of like default underscore squeeze, teleport. We could go specifically for one of those, but I just want to show you kind of like how you can drill down into where all this stuff is. So I'm just going to do underscore default. That's everything that's in default. And then now we can say like teleport if we wanted to, because that's our button press that's already associated as teleport. There it is. And then we want to get the down state for when it's actually pressed. So get state down. And then now we have to say like what specific input source it's coming from. So that's kind of like associated with like, I guess, the controller itself. So I haven't played around too much with this, but all you have to do if you're just checking for like teleport itself when it's used is SteamVR input sources dot, and then here's where you could like go through the list of if it's like from the camera, the gamepad, you know, any of this stuff that's associated. But we're going to just say any because we're just linking to teleport, which is a really simple item. And then now we'll initialize our if statement, and there you go. This big long reference here is just sort of waiting for a down state for our teleport. Okay, and that's how you write that. And if it is, we're going to say pressed is equal to true, and then if it's not, so else, pressed will be false. Got it. All right, so that's pretty good, and I guess we could just do like a quick if statement here. Like we'll say like if pressed is true, then we're gonna just print, print out that pressed. There we go. So we'll detect that real quick. Just testing. So you want to open your console to see this. I'm going to hit clear here, and then now we've got like an empty console that we can see if it happens. So I'm just going to grab either one of my handsets, and if I press it down right there, you can see here in our menu, pressed. There it is. Plenty of times, 8 times. So we'll hop out of there. Now let me go back into the script. Now we want to detect the axes itself. So we already have the axes variable created. So we just need to detect, or sort of link up the touchpad action with that. So in the same way we created this up here, so I guess I'll just put a comment here. Let's say button press, touchpad button press, or touchpad pressed. Now we're going to start processing the touchpad axis where thumb is touching it. Thumb is touching. There we go. That makes sense, hopefully, for you. So we need to make like a little local vector2 to store this, and then we'll go ahead and associate that with axis after we process it. So I'm just going to make a vector2 touchpad value. And then here's where we can associate it. So you want to do touchpad action. So if you look over here on the right, SteamVR _ action vector2 VR input, it's all associated there. And touchpad action. Oops. Fat fingered that. There we go. And we're looking for get axis. SteamVR input sources any, just like before. Alright, so the reason we created this vector2 value is just because we want to like kind of look at it and make sure it's not just 0, because otherwise we'll just print zeros all the time if we're looking at it. We also kind of want to detect when changes happen, so we're going to now go ahead and sort of like check to see if it's not 0, meaning you're actually touching it. So we'll make an if statement that states that if the touchpad value, which is this one we're assigning up here, which will receive the axis value, if any of them are not equal to vector2 0, which is basically just all zeros, meaning you're not touching it, then we're going to assign the value to axis. So axis equals touchpad value. There we go. And then we're going to go ahead and print the touchpad value here too. Only if it's not 0. Okay. Now let's check that out. So in play mode, I'm not pressing the button or touching it. Now I'm touching it. There we go. And you can see we're printing down below here in the console as I move my thumb across the surface. Okay, so if I'm in the center, it's pretty close to 0. Okay, if I go to the left, you can see the x-axis is actually going to -1, and then if I go to the right, you can see the axis is +1. If I go up, the y-axis is going to 1, and then if I go down, it's -1. So it's positive this direction and positive this direction, negative, and then negative. All right, so we're going to use that grid to help us determine where we're pressing. By the way, if you're confused on what I was just saying, I was looking at these values down here for which was getting closer to 1. All right, or -1. Now we just need to construct like a bunch of if statements that are associated with these locations. So this can get pretty confusing for you, but I'll do one, and then I'll show you where you can actually like download the script and just associate it yourself to finish it all the way out. So we'll do the top left of the handset. So the top left of the handset's going to be, let's look at it real quick. So since we're doing it in thirds, there's like a left, middle, and a right. We're actually going to use a third of the value of 1. So -1, this far that's -1. So like up here, it'll probably be like this third will be 0.3333 repeating negative. So we're actually going to do an if statement that's if the button is pressed and if the x-axis, so the horizontal axis, is less than -0.33, and so that would mean it's essentially, there's a line right here, and that'd be like -33. Let me move my thumb, and you'll see there, right about there. If you're looking down at the console here, you can see right there. That's about -33. So we want to actually detect over here, and then specifically up above. Okay, so that's good. So -0.33, and then for y, we're actually going to detect anything that's above that 0.33 because we're going positive up here. So it's sort of like if it's pressed and axis x is less than -0.33 and axis y is more than 0.33 positive, then it's going to detect any presses that are about right here. Okay. So I know that was a lot, but I'll just go ahead and put it in code here just so you can see it visually, and then now actually put it into script. So if we already have pressed processed up here, so if pressed equals true. So remember, equals is associated with if it indeed is equal to, instead of assigning pressed to be true. If you had just an equal sign, it would just associate pressed as true, but we want to check. I apologize if this is elementary for you, but there are some folks here that work in the AVL that kind of want some help from the basic level up. So if pressed is true and axis happens to be axis.x, so we're looking at just the x-axis on that, the first value, happens to be less than -0.33, and so 2 ampersands to do and axis.y happens to be greater than +0.33, then we're going to print out that the top left is pressed. And there we go. So let's go ahead and head back into Unity, and let's see if we can see this. Okay, so I'm going to clear the console, hit play. Oops. So I'm going to put my thumb up here towards the top left and press. There it is, down below here. Top left is pressed. So now if I press over here to the right, it does not say that. Right. And, however, though, if you see me pressing over here to the right, and then it actually is saying like top middle, bottom middle. That's from another script that I created I haven't shown you in this video, and the reason I wanted to point that out is because that script is available to you. It's called a handset input example, and if I run that, you're going to see it looks essentially like what we were just making. Pardon my Visual Studio house cleaning here. As you can see here, this script looks very similar to the one that we were just making, starting with the library value, the axes, that public drop-down touchpad action we made. We're processing the button press right here, and here we're listening for the axis value, and then instead of you having to write top left, top middle, top right, all that stuff, they're all here for you, and I figured out all of the axis locations. So that's available in the description below if you'd like to download this and use it. And that's pretty much it for me right now for tips on scripting input, but just know that you can always go to this input menu and sort of reference like what specifically you're looking for, and then see in this open binding UI and your local controller, you can kind of see like where these are associated. Okay, so even if like you wanted to have a menu button, when you press that button that's above the touchpad, you can add in specific actions to that button and then work with them in script. So like if I hit a button there, what you're going to end up with is what happens when you click it. So you can associate it with the actions that are in there, or you can make a new one. Say that's my menu. So you could actually make an action here that's just a Boolean and just say my menu. Save and generate. And then in your script, you would use that same technique we were using, where you're waiting for any time that's pressed to trigger something, and then that's where you would script your Unity scripting in for a menu, and you could make a menu with Canvas, which you can learn about on Unity's Learn page on their website. So that's it for this script, or that's it for this the tutorial. Thanks for watching. My name is Chauncey. If you need help from the Advanced Visualization Lab on virtual reality or augmented reality visualization, you can contact us at vizhelp@iu.edu. Thank you.